Welcome to lecture 28, Preprocessing of Text Data, second part. This module number is Analysis of Safety Reports and Narratives. Subject name is Safety and Risk Analytics. In lecture 27, we have discussed Preprocessing 1 up to parsing. When you have text documents, then starting from document standardization to tokenization, stop word, as well as punctuation filters, taming, lemmatization, part of speech tagging, phrase recognition, name entity recognition, and parsing, we have discussed in last lecture. And you have seen that ultimately every document contains a large number of words. After doing this preprocessing, you either form meaningful words, one word, multi-word, which could be said as phrase or term. Okay, so word, term, phrase. So these are the some way or other will be used in different situations. So essentially, once you pre-processed the text, and then from the analysis point of view, you require to generate word vectors, and from the word vectors you want to further generate different kind of features, attributes. So the features and attributes, they will help in analyzing certain characteristics of the system or its behavior for which the text data have been collected. Today we will discuss first what is the word vector, and then how the features are generated from word vector. So it has certain useful concepts. You have to understand these concepts. I am hopeful that within 35 minutes time we will be able to give a good introduction of the vector generation and feature generation, these two concepts. Document collection I have discussed in last class. I am not discussing further. I am assuming that you understand that you have a large amount of documents. Then the same sample records, so I can say sample documents. There are 10 documents and very brief documents we have considered. In last class I have said that these are the narratives. So every narrative is one small document, and the same 10 narratives will be considered in explaining the today's concepts. Now once you do the preprocessing of the data and you just try to find out the important words using certain programming, like you may require Python code to develop for this purpose, and then for every document you will be able to create word vectors. For example, the narrative 1, if you see, in narrative 1 there are so many words like metal, leak, so all those words after lemmatization. So what are the status? This is given in this particular slide. So we are saying this is word vector. So that means each narrative or each document having multiple words, the collection of those words, basically word vector. So I have to tell something more about this slide. Particularly, I will recall some of the things what I have said earlier. For example, the document is characterized by tokens or words. That is what we have discussed in last class, last one also. Then second is most frequent tokens are usually considered as features. Suppose the token or word, if it is meaningful and occurring mostly, then it can be considered as features. So the stop words which occurs most of the time, they are not features, so they should be removed. After that first phase of preprocessing, whatever the important words are there in the word vector, if you count that which word is occurring the maximum, so that can be considered as features, provided the word is meaningful. The collective set of features is called a dictionary. So that means what you require, you have so many words, and these words together, considering their important words, one word or in combination, the words can define feature. So the complete set of features what you will be able to develop from the word vectors, that will actually give you the dictionary. So in the safety domain, such dictionary are not available, at least to me. So what is required basically, if we work consistently for several years with real life problems, we will be able to generate dictionary. So that is very important one. From experts opinion also you can create dictionary, but please understand collective set of features dictionary. For example, metal is one word, metal is a meaningful word, leak is another word, leak is a meaningful word. So sometimes what will happen, you may be interested only leak, then this leak can be considered as an important word, and it can be a leakage of metal. So then when you consider leak to leakage of metal, that means two words combined. So that means the feature, if leakage of metal is the feature, then it is basically a combination of two words. So in that sense, meaningful features, if you can derive from the text, so the collection of all features will give you the dictionary. Sometimes also we use the words, single words, we say that dictionary of words. Similarly, dictionary of features. So it's basically depending on the purpose, the name may be used, but dictionary of features is always better than dictionary of words. Then in any document you will find out that particularly when we convert into that word vector, then each row represents document and column feature, and the cell represent measurement of the features. That is interesting part. So from word vector, okay, word vector to basically, if you want to find out the features, that means each row will be a document and each column will be one of the important features, and in the cell actually what will happen, the value that feature will take, that will be put. So essentially what happened then, you are in a structured data set. Whether the structured data, each of the values will give you meaningful information or not, or whether they are knowledgeable or not, but at least you are getting something called some rows and columns, where the rows are basically document 1 to like this, and columns are words or terms or features. But please understand, unless either a word or the term or features are meaningful, so then it will be difficult for you to extract knowledge. And the cell values, the cell values are actually corresponding feature value will be put here. Okay, this I have discussed earlier also little bit. Now with this information, what I want to do now, I want to start more about that from the word vector, how the features can be generated, and then from features, after generation of features, what more we can do, those things will be discussed. So the very basic the data, what actually from the once you the word vectors are known, this is known as spreadsheet model, and I have discussed this earlier. In the rows the documents are placed, in the columns words are placed or terms are placed or tokens are placed, and then whether these, what is the occurrence of non-occurrence of these term, tokens or even features, so that basically taken care of by putting 1 or 0. If that particular word is present in the particular document, it will be, the cell value will be 1, else cell value will be 0. This also you know, because some discussion we had on this. From this, suppose now your next important work is that you want to from the dictionary of word to, suppose you are interested to generate dictionary of features, then we have to understand what is feature. Now what is a feature? Feature is something which has certain meaning, and you will be able to relate with the particular domain. Means if I say that is a features, it will be, if I say metal is a feature, so definitely in physics we know metal and non-metal, so that sense we are able to relate it. In our domain, safety domain, so if we say metal is a features, then you have to link this with materials, so that means some kind of metals are used. Okay, so that sense you have to understand features. Now again, whether metal is important from the safety related information extraction point of view, if it is not, then that particular word is not important for us. Okay, but anyhow, it is a very tricky thing, because in any domain you will be finding out there will be lakhs of features, words, and few will be important, all will not be important. So in order to extract features, so the word pairs are very important. That means sometimes one word may not be giving you enough information, but two words together will give you more information, or two words together will basically define a feature. If you say leakage and somebody say leakage of gas, then leakage of gas is more meaningful compared to leakage, because the leakage of what is also mentioned there. That's why it is very domain specific things you have to understand. But purpose of this lecture is not just to tell you that what are the safety specific features important. No, purpose is actually I have text data, I convert it to word vector, from there we have generated spreadsheet or some other kind of document data representation, and from there we want to know how to extract features, means how to coin different words together, and what is the basis of joining the words to generate features. So I will straightway come to the formula, which is known as association measure, and we are considering this slide primarily from the book by West et al. 2010. Now, what is the meaning of association measure T? Actually, when we are talking about T, T is basically the feature. Sometimes we say phrase also, the phrase. So you can see, if you want to use term, that also you can use. So the feature T, so that means what is association measure of feature T, that is what is the uh, mm, that measure we will be using to understand that whether the word pairs are are some way significant or not, that sense. So what is the level of significance, that kind of, not from the statistics sense level of significance, that from general sense how they are associated, the two words, three words, how they are associated, that is the case. So here you see that AMT is size T, log 10, frequency T and times frequency T divided by sum of words I belongs to T, that means the term, and the frequency of word I. Okay. So I will explain each of the term here. Size T. What is the size T? That size number of words in the feature. If it is 2 words feature, then size is 2. If it is 3 words feature, size is 3. If it is 1 word feature, size is 1. So that is basically the number of words is the size. Then what is frequency T? Frequency T means number of times that feature T occurs in the document collection. In our example, there are 10 documents. So document collection means 10 documents together. In the document collection, how many times these features occur, that is your frequency. And then obviously you can find out, if you say that frequency word I, so that means how many times the word I occurs in the actually here we are saying word belong to term, that means within the term. Okay, sorry, T means basically, T means we are talking about feature, sorry, this is feature. So with this information, now if we want to calculate that what is the association among the multi-word feature trip and fall in the 10 sample records. So if you scan through the records manually, you will find out that size of T or size T is 2, because trip and fall are the two words important, so it is 2. Then log frequency 2, that means how many times that this phase or the feature occur, you will find out of 10 that there are in 2 times it occurred, and then that's why the frequency T is 2 again. So log 2 frequency 2, then divided by, now how many words are there, trip and fall, the 2 words are there. What you require to do, you require to find out the sum of the frequencies of these 2 words, that means trip and fall words 4 and 2 times this occurred. So this talking about the association between this trip and fall is 0.2. Now whether 0.2 is significant or 0.5 is important, that is a very difficult proposition. So but at least for the time being, we can find out that yes, there is association, and this association is 0.2. So we can do one thing, that you can find out the association for all the features, and then you can do a Pareto chart, that association measure vis-a-vis vis-a-vis the terms or the features. You will find out which one is mostly associated, which words are mostly associated with which feature. So that also you can do. This is very important one for all of us, because feature selection, not feature selection, feature generation is an important task here, because you have a big text, from there you are now finding out the features. Then let us see that how these 10 different cases or 10 different narratives, what are the, how do you generate the features. For example, as there are 10 small text, we manually read it, and then we are interested, after reading this, we have selected a few features. For example, for the first document, Tandi's car, fire brigade. For the second document, concrete slab. Third one, main gate. Like this. Even that means there are two features which are important in the first document. Important in the sense it is very hypothetical way it is done. It is basically after reading this, we understand from our domain knowledge, we understand that okay, these two are important features. So Tandi's car is two-word feature, fire brigade two-word, concrete slab two-word. So mostly we have written here two-word features, but there could be three-word feature. Like if I say slip, trip, and fall, then this is a three-word feature. Okay, so depends. There will be single word feature, two word, three word, four word. But when you increase the number of words, probably you will find out that again one word is may not give you good answer, good information, but two words collectively give you better information. Three words maybe, but when you increase further, you find out that meaningful features are not coming out of many words together. So, so here I can say that domain knowledge is very important in a particular domain. What are the important features? So, what I am basically trying to tell you here that okay, let us see that with this document, if these are the features, how we will use the in whatever we have discussed so far, the association measures. The association values, association measure values, as AM we are saying the association measures for the different documents. So we have 10 documents, then the feature and their size, their frequency, and whether they are one word, two word. For example, Tandi's car, that is basically two word. Tandi's appear 4 times, car appear 16 times. So that way all those informations are generated, and using the formula given in the previous slide, we found out that what are the AM measure. Okay, so that is first part. Now, if you now further do little bit analysis that okay, we have so many features now based on AM. Let us see that what is their status in terms of association. So, if you arrange them, you will find out that so this one, this 0.24, 0.3, 0.24, mostly 0.24, 0.3, and this kind of association we got. So we can say yes, these are significant association. In the sense, 0.2 is not bad, or 0.24 is a good association. So now, if we want to conclude here that whether based on that AM association measures, which are the features you want to keep, perhaps you see that there are so many features together, but we are basically keeping a few of them, and that is what is keeping here up to CO gas, that means more than 0.2 I think we have considered, but you please check that means point, yeah, that is 0 not considered, 0 not considered, 0 0 0 0 0. Okay, there are many zeros, so automatically they are not considered, but need not be that zero value will come all the time. So because of the formula, that zero might be coming, but and the our document size is also small. So if you have bigger document, so definitely this zero you may not get. You may get even more values for measures. This is good to know that okay, that means from the big text at least something understandable level is generated using a formula called association measure. We can do more. So what we can do, let us see. After that, term document matrix. This is another important concept in text analytics. So the word I said, the word term or word or feature, phrase, So those things, whatever way you use, the commonly if you say term, that also, at least to me, it basically suffix, but from the text English terminology point of view, there may be little maybe, I am not sure, little objection, but let us understand what is the term and document matrix. Basically, as we have already discussed, suppose there are m number of documents and n number of words, then when you are making a spreadsheet where the rows are documents and columns are words, so that basically represent a matrix, and that matrix is called term document matrix or TDM. So this one we have discussed earlier, TDM, and in TDM the cell value, the frequency of the term is basically placed, and TF-IDF, term frequency inverse document frequency, is also calculated just to understand how the term is important with reference to the document. Okay. So for the time being, then you can understand that what is term, that your rows are documents and columns are term and cell values are the frequency of occurrence, that is known as TDM. And in addition, I think if you, when you create TF IDF matrix, that means here the document 1 or document 2 and the term, all those things should remain same, but only this value will change, cell value will change to TF IDF value. So we will discuss now how the TF IDF values are calculated and what are the meaning of these values and how the TF IDF values will be used in the safety domain. Okay. So apart from this, you just that you have to understand what is the term frequency. Now term frequency, I am reading it very clearly, it is written there that you are talking about term J in a document D is the number of times that J occurs in D. You consider any term, for example, earlier we have seen Tandis car, that may be if we say the term, or Tandis itself, if we consider Tandis is the term. So then basically, and if we consider the fifth narratives, then how many times Tandis occurs in the fifth narrative or the fifth document. So that is called term frequency. These are very simple thing, but as we are using TF, JD, this kind of symbol, so it looks to become complicated, but it is not. TF means term frequency, J means the term, and D means the document. Okay. I think that how do you understand that what is the meaning of term document, a term frequency. Suppose for a particular word term frequency is 10 with reference to another word where term frequency is 1 in a particular document. So that means the term which occur 10 times definitely having more relevance than the word which appear 1 times. But please keep in mind, this is not 10 times more relevance. That is another important one. So that way means term frequency gives you an idea that if a term appears more number of times in a particular document, it has relevance, more relevance compared to a term which appears one time. But you cannot say that it is 10 times more relevant. So that means it is not proportional. Okay. So, but at the same time, if a term occur very less times, so we cannot say that that is not important also. So you have to understand that this is a very tricky game. So that's why term frequency alone may not be that much important all the times. You may require to have something more. we will discuss that one, that IDF, inverse document frequency, and TF IDF, term frequency and inverse document frequency. But before that, just how the term frequency can be used in different ways, that is basically given here. When we are talking about binary spreadsheet representation, when if the term is present 1, otherwise 0, irrespective of the frequency of the term in a document, that is one way of representation. Second may be the term frequency itself, what we have discussed so far, that okay, for a particular document the term and how many times it appears. Third may be as term frequency is not proportionally related to the term is not as relevant proportional to the number of times it occurring. So that's why you may use some other kind of system. Suppose if doesn't occur 0, if it occur once 1, if it occurs 2 or 2 to 3 or 2 to 4, that may be 2, or beyond 4 it may be 3, something like this. So there are many ways you have to you can fill up this table, that term document term, that term document matrix. So that is, there are a lot of flexibility, and but this flexibility is not hypothetical flexibility, it is based on the domain specific flexibility that you have to use. Let us discuss with the cases. So what you are seeing in this particular slide. So first the 10 narratives and the ultimately different terms. Particularly we have basically considered that single words here, and we have chosen these terms with reference to the words which are relevant to hazardous elements. In hazard triangle, you have seen that hazardous element, accident causing mechanism, and target and threat, these are the three vertices, an important thing for the safety engineers. So we have found out that okay, what are the words relevant to hazardous element that we have put here, and if you see that the table is nothing but the term frequency table, because the frequency values are put under the cell. Now hazard elements are important, so that's why we are basically considering that not all the terms, those terms which are valuable for us in terms of hazardous elements. Okay. Now the terms and respective frequency are paired and stored in parchment. Another one important one is that if you want to reduce the storage space, so that from this term frequency matrix to parse vector you can generate. What is the parse vector? Because you see the term frequency matrix will contain many zeros. That's many zeros. That means it's parse. So what is the point in keeping so many cells where it is the value is only 0? So that's why instead of the spreadsheet model to the parse vector model, if you go, what you will write basically, you write basically parse vector in the form that, for example, here if I consider the spreadsheet row 1, that first term 0 value, second term 15, third term 0, and fourth term 3 times. So that means our occurrence point of view 15 and 13, and the term point of view, that is the second term and third term. So first word is term, second word is frequency. So in that manner also you can write down this term frequency data. So for the sample case you just see that how it is reduced. So much a big big template or big data, big in the sense large compared to this one, not from the big data point of view we are talking about. So narratives and their term document frequency, so it basically help you reducing the storage space. So this is known as parse vectors. These parse vectors are also used in text mining or text analytics. So, in the similar manner, we have developed term frequency for incident causing mechanisms, term frequency for target and threat for the 10 documents or the 10 narratives. Now, see that for incident causing mechanism, so we have chosen those terms or the words which are basically related to incident causing mechanism, or for incident causes can be related to those terms. So, here again you see that the term frequency matrix and then your sparse vector, and why we are interested in that term frequency for incident causing mechanism. If you say ICM, that also good to write. Okay. Now, let us see that similarly for target and threat also, similarly for the threat, target is very simple, that either people, property or environment, but threat can be of different types. So, the threat related terms are considered, and then we prepared another matrix called term frequency matrix for threat. So, and the parse vector related to this. So, your work will be maybe in the examination point of view. I will be giving you some kind of word vector, and will be asking you, okay, you generate hazard triangle from the data. So, that means you have to find out that what are the words likely to represent hazardous element, what are the words likely to represent incident causing mechanisms, what are the words likely to represent threat. Then at least these words, either single word or two words together in terms of phrase or in terms of features, if you develop this kind of term frequency table, that will help you in preparing the hazard triangle. We'll discuss that also. Then come to the term frequency and inverse document frequency, how it is computed. So, this is computed using this formula, that and this formula. So, that means I have already explained what is TF, term frequency, JD. Now, you require to know what is inverse document frequency. Inverse document frequency is log of capital N by DFJ. Okay. So, you can understand that the different terms, the notations what we have used here. So, DFJ is the document frequency, J document, that is the in the sense that which contains the term J, that is basically we are talking about. So, DF is the document frequency, that means number of documents that contains term J. Out of 10 documents, if this term is available in 2 documents, then DF is 2. So, N is the total number of documents. Now, log N by DF is used instead of N by DF to dampen the effect of IDF. Okay. So, rare terms are more informative than the frequent terms. So, see, earlier from the association, and also we have discussed from the term frequency, we said that if a term appears more frequently, it is carrying more information. Here we are saying that rare terms are more informative than frequent terms. So, that means there is contradiction, but the reality is like this. So, that means you have to consider both the things together, and then you have to create a proper measure which basically gives you some kind of weighted importance, and that is nothing but TF IDF for term J. So, what is TF IDF? TF IDF is nothing but term frequency J multiplied by inverse document frequency J. Inverse document frequency from this formula, term frequency earlier we have discussed. So, multiply the two, you now get that for each of the cell another value called TF and IDF for the term J. So, let us see what is this. Now, what are the why this TF and IDF is significant? First part is okay because when you want to use the machine learning algorithms, they want in some kind of data means some kind of numbers or matrix or numbers, it basically it is required also, that's fine. Now, when we convert the document to word vectors, again the words are basically being words that you can convert into frequency also. So, first part, as we told, that obviously that some kind of quantification in terms of value of the terms or features are done in this manner, and at the same time basically what I mean to say that this talks about something, some value which are meaningful, that what we have discussed so far. So, fine. So, with this I just want to tell you, for example, term frequency. Now, in safety domain, the term frequency, suppose if we find that a particular energy source is coming several number of times, that means the term that particular source is basically causing more problems. So, that's why term frequency is very important. And as we have already discussed that if a term appears several times in several documents or maybe in all the documents, then it is not carrying that meaning from the difference in the documents point of view. Number two, that may be some kind of common information or commonness in the term. So, that is why the document frequency is also important. And TF IDF, as I told you, that basically it's basically some kind of weighted information, the term which is carrying, and perhaps this is more relevant, and that's why most when we will be using the machine learning techniques from the clustering point of view, document classification point of view, most of the times we may be relying on TF IDF matrix rather than the spreadsheet 1-0 binary matrix or term frequency matrix. Now, see that for the 10 cases, the term frequency IDF values computed and given here. So, what is the meaning of those things? Now, let us see that all the features or the terms and then what are their TF IDF scores. So, as we are interested in HEs, we are interested in incident causing mechanisms, we are interested in threat. So, we have divided them in 3 different groups. The features related to HEs, what are their TF IDF score, and related to IM TF IDF score, and relating to threat TF IDF score. Okay. So, then you can with the score you can find out which one is more important than the other one. Let us see that this is a plot, basically TF IDF plot, basically that you see this is the score, and this is some kind of Pareto principles we have used. So, first 5 terms have maximum TF IDF, term 1, term 2, 3, 4, first 4 terms I can say that maximum. Then the rest these many terms having constant TF IDF means similar, and then there is a fall, So, now here you can consider the first 4, you may think that these first 4 are important, or if you may consider up to this. Okay, so if you think that this value, the value here point one something, this is important, then you can do like this. So this gives you a fair idea that what are the terms which are basically important if we consider TF-IDF, that conversion, that particular value has significance for the domain where we are applying it. Now with this, for the 10 documents, see, we have created terms of IM, terms of HE and terms of threat, and we are saying that if you have large number of documents also, with the algorithm, the Python code we have developed and we made it. So with the algorithm you will be able to generate the hazard triangle. For example, you have lot of safety audits or inspection records, or your I can say investigation records, some kind of HAZOP and other kind of studies also there. But if you want to use those documents to develop the hazard triangle, yes, it is possible using text analytics, but it is not a easy task. You have to have the experts who will be able to identify appropriate terms for the three elements of the hazard triangle, and then you have to use the machine learning algorithm appropriately, and then you will be definitely, I am saying that you will be able to generate this. This is interesting and useful also. Now another important part I want to discuss here also, but I'll take another 3-4 minutes. Now what is this basically? Fine, I know that the terms of features what we have discussed earlier, you have seen the features, fantastic. But if all the features are important, from the Pareto principle you found out that some of the features are more having more TF-IDF value, but others are having large number having the same TF-IDF value. But can I find out some measure by which we can assign some kind of importance if we keep that particular feature, so that is we are gainer or not, something like this. So that is known as feature selection. That means which out of so many features, which one you will select, and that selection with the help of your attribute ranking. The attribute ranking, this one I have taken from Wish et al. Book. There the information gain criteria is used, where basically you can find out that there are many things again. First formula is for information gain, then here L label, that is one term is used, then L within bracket J is used. Now what is L label is given in by this formula. Then what about Y and what about C? That is another thing you have to understand. At the same time, if xj is basically assuming v value, what is b? So you require some explanation of each of the things. Okay, so here this L stands for number of bits required to encode the label. So this kind of language used in information system kind of things, basically the quantification of information, that Shannon information criteria, these things are there, but we are not expert in this particular domain. So what we require, basically we have to use this formula and we have to understand how to compute the information gain. So I will explain each of the term with the example, and so that you will also be able to understand it in a better manner. So let us see next what is the example we are considering. Example is this. So this example you have seen earlier, but what is the additional thing we have used here? Because we want to find out that which document, which feature is more important, but importance to a feature can be assigned with reference to certain purpose. So here that we have created that kind of some kind of class variable here. That class variable is basically that observation type, either unsafe condition, unsafe act, or something like this. That two groups, basically two classes, basically we consider unsafe condition and unsafe act. So that means this is the additional criteria we are using in order to compute the information gain. Now see what is happening here. These are the formulas what already I have shown you. I have not discussed each of the terms, but if I want to discuss by J, C, something like this, you will be at loss. So what actually required here is, first you understand, let J is the term which is basically the fall, okay, or if I say the feature, no problem, that fall. Now we are creating n equal to 10, that is the number of documents fall each. That means basically 10 is the number of documents where fall is present. As number of documents 10 we have considered. Now number of documents where fall is present, that is basically 4. Okay, now if we want to use this formula, then how we are using it? Now probability fall equal to 1. Okay, so in 10 documents fall equal to 1, the term value is 1. And how do you compute this one? You will be computing this one using this formula. So that means the xj term is basically fall. That fall has occurred, the value b is basically we are talking about 1. So that how many, that then frequency you have to find out how many times or in how many basically documents this is there, plus 1 divided by n plus 2. So if I want to say that probability fall equal to, for that the documents basically that content this fall equal to 1. So in that sense, this frequency xj, how many, what is this number is 4 plus 1 divided by n is 10 and 2, so it will be point, I think 0.4176 something will be there. So in the same way, in how many cases that or in the how many documents that this particular fall is not present, so that time what will happen, v will be 0 and you will find out that value is this. So it is with reference to all the documents together. So what actually, let me repeat, we have 10 documents, we are considering the term of the feature fall, and we are finding out that for a particular document whether it contains fall or not, what is the probability. So that one, that means fall equal to 1. So then 4 documents contain it out of 10 and formula is used here, and this formula gives you this value. Similarly, the same formula gives you the other one when fall is not present in the document. Now after that, what actually required, another one is required, that we created the two class, what is unsafe act and unsafe condition. So the C, meaning of C now you can understand, that C stands for class. So that means what we are saying, that we are creating class variable y equal to C and given xj equal to fall. So that means y equal to unsafe condition given that xj equal to fall or fall equal to 1, that sense basically. So in this manner you can use this formula and you will again find out that out of 10 documents there are certain documents which talks about unsafe act, other documents unsafe condition. So if I go back, I can tell you that unsafe condition, okay, 6 document unsafe condition and 4 document, I think, unsafe data, unsafe act, 4 document unsafe act. So now using this, that means you segregated under 2 different groups, unsafe act group, unsafe condition group. Now you are using the, what is the probability of fall equal to 1, given that the class C is unsafe act or unsafe condition. So in this way you have to use the formulas. Okay, so I will not explain further, because this is in a similar manner. So you are getting probability fall equal to 1 given C unsafe act is this, condition is this. From 0 point of view you are getting like this. Now here what happened? Next you want to create L label. This L label formula is this. So you find out this one, and then finally you find out that what is the L fall. L fall related things you find out, then L label minus L fall, that will give you basically what is the basically that Ig L label minus Lj. So that you just check this, whether this computation is correct or not. So probably, yeah, just check it. But this is the way. So you have to start from the down and go up, and slowly that finally you will be able to find out the information gain, where L label minus Lj, and L label you are finding out in this formula, and Ij you are finding out with this formula. So with this I want to close that. Yes, from the text to word vector to spread table, spread table to term document matrix to TF IDF term document inverse term frequency inverse document frequency matrix, and then from there now actually you are basically finding out that what are the terms and their importance, and then finally selection of features, which are basically in terms of terms we have discussed here. Okay, so thank you so much. We have taken these references are given here. Okay, see you again.